Hello out there, welcome to this tutorial on binomial expansion. In this video, we'll be looking at binomial theorem. This is lesson 5. If you are joining us now, check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on binomial expansion, including the Pascal's triangle. So we start with problem 1. For problem 1, given that 1 plus px all to the power of n is equal to 1 plus 18x plus 135x squared plus qx cubed, and so on, find the values of the constant np and q. We carry out the binomial expansion up till 4 terms. So the first term is going to be n combination 0, 1 raised to power n. There might not be need for px raised to power 0 here. So we go to the next term, plus n combination 1, 1 raised to power n minus 1, then px raised to power 1. Then the next term plus n combination 2, 1 raised to power n minus 2, px all squared, plus n combination 3, 1 raised to power n minus 3, then px all to the power of 3, and so on. Then simplifying this, we have n combination 0 gives 1, then 1 raised to power 1 is still 1 also. So we have that part as 1. Then plus n combination 1 is n factorial over n minus 1 factorial 1 factorial, then multiply by px. Since 1 raised to power n minus 1 will give us 1, then multiply by px gives px, then plus n combination 2 is expanded as n factorial over n minus 2 factorial 2 factorial, then p squared x squared. If you expand this, for now we are going to stop here. We don't want to continue with the expansion. It continues, but we'll come back to this later because we need these first 3 terms to get the values of p and n. Then thereafter we now substitute to get our q. So this is 1 plus, we can then simplify this. In our simplification, we have n factorial over n minus 1 factorial 1 factorial. Expand this as n minus 1 factorial over n minus 1 factorial times 1. We are stopping at the expansion where we have n minus 1 factorial because we have n minus 1 factorial at the denominator, where this n minus 1 will go with n minus 1, we'll be left with n. So we are left with n, then multiply by px. Then this is plus, we expand this one also, which is giving us n factorial over n minus 2 factorial into 2 factorial. And we are going to expand this one up till n minus 2 factorial. So we have n into n minus 1, then n minus 2 factorial over 2 factorial, then times 2, since 2 factorial is 2. N minus 2 factorial will cancel n minus 2 factorial. Then we are now left with n over 2 into n minus 1, then multiply by p squared, x squared, and so on. So from here now, we compare with the right hand side of the original equation. You discover that 18x is corresponding to npx, that is the coefficient of x, which means np is equal to 18, since the coefficient of x is 18 here and the coefficient of x here is np. So where we now have p is equal to 18 over n, we call that one equation 1. Then we go for the term in x squared. So these are the terms in x squared. So it means n over 2 into n minus 1 p squared is equal to 135. We call this equation 2, and we put 1 in 2. Wherever you see p squared, we are going to square this and substitute. So we are going to have n over 2 into n minus 1. 18 squared is 324 over n squared is equal to 135. So n, we remove one of the n's here, and 2 into 324 gives 162. 2 goes into 2 to give us 1. So we are left with n minus 1 into 162 over n. We can then cross multiply from here. We have 162 into n minus 1 is equal to 135n. Expanding this bracket, we have 162n minus 162 is equal to 135n. So collecting the like terms, we have 162n minus 135n is equal to 162, where 27n is equal to 162 and n is equal to 6 after dividing 162 by 27. From equation 1, we substitute in the value of n. So that's p is equal to 18 over 6, since n is equal to 6. 18 divided by 6 gives 3. Then we go ahead to get the value of q from the fourth term of the expansion. That is the coefficient of x cubed. So from here you can see q is equal to the numerical part here, which is n combination 3 and 1 raised to power n minus 3 p raised to power 3. So this is x cubed here, x cubed here. So we can then go ahead to substitute in the values of n. So we have q to be 6 combination 3, and here we give us 1 raised to power 3, then 3 raised to power 3. So we simplify. 6 combination 3 gives 20 times 27. Since 1 raised to power 3 gives 1 times 27, which is 3 raised to power 3. This gives 540. So we have successfully gotten the values of the constants n, p, and q, where n is 6, p is 3, and q is 540. We are done with problem 1. We then go to problem 2. For problem 2, the coefficient of x3 in the expansion of 1 plus kx all to the power of 9 is 10,500. Find the value of the constant k. So in our solution, we know the term in x raised to power 3 is 9 combination 3. This is going to be 1 raised to power 6. That's 9 minus 3, 6. Then kx raised to power 3. So this is it. Therefore, we can just get our coefficient of x3, which is going to be the numerical part here. That's going to give us a 9 combination 3, which is 84. Then k raised to power 3. Since this is x raised to power 3, we are only interested in the numerical part there. That is the coefficient of x raised to power 3. And we are told that the coefficient 10,500 is equal to 84k raised to power 3. So where k raised to power 3 is equal to 125 after dividing 10,500 by 84. So we have our k to be equal to 5. That is cube root of 125. Or you look at it as 5 raised to power 3 gives 125. That's all for problem 2, since we have found the value of the constant k to be 5. We then go to problem 3. For problem 3, The term independent of x in the expansion of x plus k over x squared all to the power of 12 is 7,920. Find the value of k. Since we are looking for the term independent of x, any term of the expansion is 12 combination r, then x raised to power 12 minus r. This k over x squared will be transformed into indices. That will be kx raised to power negative 2. So we have kx raised to power negative 2 all to the power of r. The term independent of x is the term in x raised to power 0. So in that case, it means when you add the indices of the part involving x, you are going to have it equal to 0. So we have 12 minus r minus 2r is equal to 0, which is going to give us 3r is equal to 12. So from here, r is equal to 4. The term independent of x is the numerical part here, which is 12 combination 4, k raised to power 4. And we are told is equal to 7,920 as it is given in the problem. So 12 combination 4 is 495, k raised to power 4 is equal to 7,920. Dividing both sides by 495, k raised to power 4 is equal to 16. Since 2 raised to power 4 gives 16, therefore k is equal to 2. And that's all for problem 3. We then go to problem 4. For problem 4, given that the coefficient of x squared in the expansion of k minus x into 3 plus x over 3 all to the power of 5 is negative 120, find the value of the constant k. To find the solution to this problem, the term in x squared is going to be k times the term in x squared plus negative x times the term in x, when we are using this to multiply the second bracket, that is with respect to 3 plus x over 3 all to the power of 5. So for this now, we are going to have it equal to k into the term in x. For this expansion, it's going to be 5 combination 2. Then the first term in the bracket there is 3 raised to power 3. 5 minus 2 gives this 3. Then the second part of the bracket, x over 3 squared. This, so we have that part there, then plus negative x into the term in x, that's x raised to power 1. So we are going to have it as 5 combination 1, 3 raised to power 4, then x over 3 raised to power 1. So simplifying this now, we have k into 5 combination 2 gives 10, 3 raised to power 3 gives 27, x squared over 9, then plus negative x into 5 combination 1 gives 5, 3 raised to power 4 gives 81, then into x over 3. Okay, now the coefficient of x raised to power 2 here now, that's x squared. It's going to be simplifying this, and we are only interested in the numerical part. So we are going to have it as 27 divided by 9 gives 3, 3 times 10 gives 30, times k will give us 30k, then plus 81 divided by 3 is 27 times 5 will give us negative 135. If you multiply by this coefficient of x here, which is negative, This is equal to negative 120 as it is given in the problem. The coefficient of x squared in the expansion is negative 120. So solving this equation, we have 30k. We take this negative 135 to the right hand side. It becomes 135 positive, then minus 120. So we have 30k is equal to 15. Dividing both sides by 30, k is equal to 1 over 2. And that's all for problem 4. We then go to problem 5. For problem 5, we have a and b. First we expand. B, use your result in a to evaluate 1 plus root 3 all to the power of 5 and 1 minus root 3 all to the power of 5. Hence, evaluate 1 plus root 3 to the power of 5 plus 1 minus root 3 to the power of 5. So we start with a part of the problem. So in our expansion, we have the first term to be 5 combination 0, then 1 raised to the power 5 plus 5 combination 1, 1 raised to the power 4, then x raised to the power 1 plus 5 combination 2, 1 raised to the power 3, x raised to the power 2 plus 5 combination 3, 1 raised to the power 2, x raised to the power 3 plus 5 combination 4, x raised to the power 1, then x raised to the power 4, and finally plus 5 combination 5, x raised to the power 5. So simplifying this is going to give us 1. This is 5x, that's plus 5x. This is going to give us 10x squared plus 10x squared, then plus 5x raised to the power 4, then plus x raised to the power 5. So we are done with the expansion. The next thing is the b part of the problem. From our result, according to the question, in a, wherever we see x, we put root 3. So we have it as 1 plus 5 root 3 plus 10 root 3 squared plus 10 root 3 cubed plus 5 root 3 raised to the power 4 and finally plus root 3 raised to the power 5. We then go ahead to simplify. This is 1 plus 5 root 3. Root 3 squared is 3 times 10 gives 30. Root 3 raised to the power 3 gives 3 root 3 times 10 gives 30 root 3. Root 3 all to the power of 4 is root 81, and root 81 is 9. 9 times 5 gives 45. This is going to give us 81 times 3, which will give us 9 root 3. So we now have the rational and the irrational components of the expansion. We simplify them. 1 plus 30, then plus 45 gives 76. Then 5 plus 30 plus 9 gives 44, then root 3. And that's all for the evaluation of 1 plus root 3 all to the power of 5. Then we go for 1 minus root 3 all to the power of 5. What we just do here is change the sign here. Since this is plus, it goes with plus here. We're having minus here, we just change this also to minus, because from here now, if we are to go fully by expansion, we will just attach minus here, which means this is coming as negative, this is coming as negative, and this is negative. So negative 5, negative 30, negative 9 would have given us negative 44. So the expansion to this is 76 minus 44 root 3. We then go ahead to evaluate their sum. That is 1 plus root 3 all to the power of 5 plus 1 minus root 3 all to the power of 5 is going to be addition of this and this. So this is 152. Since this minus this will give us a 0. And that's all for the solution of problem 5. This is the highest we can take in this tutorial. I hope you enjoyed it. Please like and share this video. Remember to subscribe to our YouTube channel if you have not done that. Also check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on binomial expansion, including Pascal's triangle. Until we come your way again, goodbye.